Hey everybody, we got an interesting one for you this week. I think we've all seen this done on the internet, but I wanted to put a process around it on how to make a worm gear, predictable worm gear, so you know what the tooth count's going to be. Here's a small 60 tooth worm gear being made, and this is a large 117 tooth gear, both being made by a tap. Secrets in knowing what the outside diameter of the gear blank is. So here's our calculator. Among other things, you get to put in the gear ratio you want, hence the tooth count, and it gives you the outside diameter of the blank so that when you use your tap to make it, it gives you the right tooth count. Important detail. The depth of cut's also in there that is necessary so you get good engagement. And, you know, here are the highlights. Tooth count, threads per inch, and hardware size. All those can be converted into normal gear language. This helps us make these calculations, predictable OD outputs. The cool thing about this project is it brings some pretty precision gearing manufacturing to a lot of shops that have these minimum capabilities. As we get started here, let's talk about materials. A common gearbox for worm gears has a worm gear that's made out of bronze, like this one we're turning here, and then it uses a hardened steel worm, usually polished, and the pair makes a very large gear ratio reduction. So again, bronze is normally the worm gear, steel is the worm. Now we're going to buy a 1/4-20 high strength bolt and use that for our worm, and then we're cutting the worm gear blank as we speak here. So that's what we're using for materials in the case of this example, our 1/4-20 example. So this is something, you know, I'm using a really big engine lathe here, but that's totally not necessary. You could do this with a mini lathe for sure, because the tool pressures aren't that great for bronze, and we're not making that much of a cut here in any way, shape, or form. So now we're just going to face the end off, put a hole in this thing. Now we're using 1/4-20 hardware, and we're also going to put a 1/4-inch hole in this thing because it's going to go in an electronics project when we get done. And so we're just facing this off to the end. The reason bronze is used, bronze and steel, that combination for worm gearing, is they slide really well against each other. There's very favorable friction characteristics of bronze on polished steel. As well, you know, you're not going to use the tap to turn this. In practice, you're going to use a bolt. So you'll run it with a bolt for a while to kind of wear it in, run it in as it were before you use it. So we'll end up doing that with this set. Now we also, I just want to show this is a 1/4-inch rotary tool set that we made for 1/4-inch tools. And so the drill bits there on the bottom, the ones on the left, are for prepping the ream and interference type fits, and the ones on the right are for through holes, and the ones right in the middle are right on the money at 1/4-inch. There's reamers, counter bores, countersinks, flat carbides, tapping tools. So it's a pretty comprehensive kit of what you need. It makes some of this prototyping really quick and easy. I'll probably attach a file on that in Patreon as well. There's definitely a file in Patreon that shows the numerical model and allows you to use that spreadsheet to design your own worm gear set and use this whole process. So we'll go through cutting the worm gear here in a minute and what the pros and cons are there, and some of the methods to maybe improve on what we're going to show. This is just using some cool mist and cross slide here to cut this off. I'm going to put a file to it, get a chamfer on the end, and then before I fully cut it off, get a little back chamfer there. So we've got our blank cut out. It's the right size for our worm gear, and it's got the right bore. And of course, you go to your tap set, and we'd like to use a bottoming tap. And of course, all my tap sets are not complete, but this one is. So we'll use the bottoming tap as for this project because it's got full form teeth quite a ways down it, and we'll use kind of the central portion of it, as you'll see here in a minute. And there's just a regular 1/4-20 bolt. The bolt mimics the tap makes the hole for the bolt to go in. So normally when you're using precision gears, your hob is going to be slightly bigger, just a few percentage points bigger than the worm you're going to use to allow for proper lubrication. But again, this is a shortcut for fine pitch gears, and it generates really good results. In this case, you know, when you need to make just one, we thought we'd figure out how to do this in a more approachable way for everyone that doesn't want to buy an indexing hobbing machine. I just thought I'd add some process around it so that you could go into this having some confidence you're going to get what you want out of it. So you want your blank to be free spinning, and you want to go ahead and engage it fairly quickly, as you'll see, in terms of depth of cut. So maybe go in 10,000ths and so on. But a gradual startup is going to give you that little skid mark there, which we don't really want. We want to be engaged enough so it'll index itself. That's what's going on here with free hobbing. It's indexing itself around in a circle, and the hob is providing all of that motion. The tap. So we're just increasing slightly, maybe 3 or 4 or 5 thou per revolution until we get our depth of cut reached, which is about 30 thousandths. You can tell as you're doing this that the indexing is actually quite good. The spaces are very even between the teeth being cut. That's a great sign that your process is working properly. We're getting close here, but it would work a lot better if you had a cool mist system or something on it to move these chips out of the way. You don't want them to get recut in there and mess up the tooth form. There's also a very temporary fixture on the cross slide on the lathe. You could improve on that substantially. There's just a 1/4 bolt locked in there with a bearing on it to kind of hold this gear blank up to the right center height of where the tap is. So it's just spinning around just fine. It looks like we've cut to full depth for sure, and maybe a little beyond right here. And when you get near the end, you want to pull out really quickly so you don't mess up some of the teeth. And it yields really good results. It looks crisp and nice on bronze, and yeah, that was a good cut. So this is a great validation of the model. 62:1 gear ratio. We measured it, we cut it. We also came back in and made a 60:1 gear ratio, different OD, and then 117 teeth gear ratio setup. Hope you guys enjoyed this. Hope this allows you to make a few extra things in your shop, and we appreciate your time and watching. Thanks again. Don't forget to look in the description. There's always lots of great stuff there, and jump on over to our Patreon to get those files.